What is the main motivation behind developing the SUTRA model?
The main motivation behind developing the SUTRA model is to address the inherent limitations in existing multilingual large language models, LLMs. The SUTRA model aims to bridge the gap between market demands and the current capabilities of LLMs by mitigating linguistic inequality present in recent multilingual models. The goal is to develop a model proficient at performing downstream tasks in any supported language, eliminating the necessity for multilingual speakers to default to English for prompts. The SUTRA model uniquely separates the process of concept learning from language learning, allowing the core model to focus on universal language, agnostic concepts while leveraging specialized neural machine translation, NMT, mechanisms for language-specific processing. This approach preserves linguistic nuances without compromising the model's scalability or performance. Additionally, the SUTRA model aims to provide internet-connected and hallucination-free models that can understand queries, browse the web, and summarize information to offer the most current answers, enhancing the model's real-time capabilities. Ultimately, the SUTRA model promises to redefine the landscape of multilingual language modeling by offering a more inclusive and efficient solution for diverse linguistic landscapes.
How does the proposed method or algorithm work? Illustrate step by step.
The proposed method, SUTRA, works by decoupling concept learning from language learning in a multilingual large language model architecture. The process unfolds in 3 phases: concept learning, and language alignment. In the concept learning phase, the core model is trained to grasp concepts in a small set of languages. Simultaneously, specialized neural machine translation, NMT-based encoders and decoders, along with a multilingual tokenizer, are trained to master multi-language translation and ensure concept consistency across languages in the language learning phase. Finally, in the language alignment phase, concept understanding is merged with linguistic proficiency. During inference, input is processed through an NMT encoder, then the concept model, and finally through the NMT decoder to produce the output. The architecture of SUTRA is built upon the transformer architecture, with enhancements like extended dense context length and MO layers for efficiency in computation and memory consumption. The model utilizes a mixture of experts, MO, strategy, engaging only relevant experts based on the linguistic task at hand. The training data strategy leverages linguistic commonalities during language learning, incorporating over 100 million conversations in real and synthetically translated pairs across various languages. The model's tokenization process involves training a sentence-piece tokenizer on a large multi-language dataset, merged with a pre-trained English tokenizer to increase vocabulary size and reduce token consumption across languages. SUTRA is evaluated on the Massive Multitask Language Understanding (MMLU) benchmark, showcasing consistent performance across languages and outperforming leading models in multilingual tasks. Additionally, SUTRA models are internet-connected and hallucination-free, providing factual responses with a conversational tone by leveraging real-time knowledge from the internet.
What are the practical benefits of using SUTRA compared to existing multilingual models?
The practical benefits of using SUTRA compared to existing multilingual models lie in its ability to maintain consistent performance across a variety of languages, ensuring robust multilingual capabilities critical for global applications. SUTRA excels in concept and language modeling, enabling it to achieve stable scores across languages, even in those less commonly represented in language models like Hindi, Gujarati, Tamil, and Korean. This consistency sets SUTRA apart from leading models such as GPT-4, GPT-3, 5, and Llama 2, which often experience a decline in performance in non-English languages. SUTRA's universal language-agnostic approach to AI makes it a reliable solution for international businesses, educational platforms, and cross-cultural communication, setting a new benchmark for large language models, LLMs, in a multilingual, interconnected world. Additionally, SUTRA's online connectivity and hallucination free capabilities allow it to provide factual responses with a conversational tone, leveraging real-time knowledge from the Internet to offer up-to-date information, making it superior to competing search engine, augmented models like Google's and OpenAI's GPT-3. 5. In responding to time-sensitive queries.
How was the SUTRA model validated or tested in the paper?
The SUTRA model was validated and tested in the paper through a comprehensive evaluation on several benchmarks, including the massive multitask language understanding (MMLU) tasks. The evaluation aimed to assess the model's performance across a variety of natural language understanding (NLU) and natural language generation (NLG) tasks. The paper outlines the use of the machine translated version of the MMLU benchmark to test the knowledge and reasoning capabilities of the SUTRA model. The MMLU benchmark covers 57 subjects across STEM, humanities, social sciences, and more, ranging from elementary to advanced professional levels. The evaluation required the model to answer multiple choice questions, demonstrating nuanced comprehension and reasoning abilities to measure the depth of knowledge and interpretive skills of the model. Additionally, the paper discusses extending the MMLU evaluation to multiple languages, focusing on English, Korean, Japanese, Arabic, and Indian languages to assess the model's effectiveness across various tasks and linguistic contexts. The SUTRA model demonstrated consistent performance across different languages, showcasing robust multilingual capabilities critical for global applications. The evaluation results compared the SUTRA model with leading models such as GPT-4, GPT-3, 5, Mixtral, Llama series, and others on the multilingual MMLU benchmark, highlighting the SUTRA model's ability to match or even outperform these models in providing natural and engaging responses across languages. The SUTRA model excelled in comprehending and generating responses across numerous languages, even surpassing models specifically optimized for a particular language, demonstrating the effectiveness of the SUTRA approach in multilingual language modeling.
What were the specific results achieved by the SUTRA model in the MMLU benchmark?
The SUTRA model demonstrated consistent performance across various languages in the massive multitask language understanding MMLU benchmark. It exhibited minimal performance deviation from English to languages like Hindi, Gujarati, and Arabic, showcasing its robust multilingual capabilities critical for global applications. The model maintained stable scores across different languages, unlike other leading models that often regress to baseline random chance performance in non-English languages. Specifically, SUTRA outperformed GPT-3, 5 and Llama 7B on 2 related use cases by excelling in comprehending and generating responses across multiple languages. It surpassed GPT-3, 5 multilingual performance by 20 to 30% on the MMLU benchmark, indicating its superior performance in understanding and responding to a wide array of tasks across diverse linguistic landscapes. Additionally, SUTRA's ability to maintain consistent performance levels in languages less commonly represented in language models, such as Hindi, Gujarati, Tamil, and Korean, sets it apart as a universal, language-agnostic solution for international businesses, educational platforms, and cross-cultural communication.
What are the limitations or drawbacks of the SUTRA model proposed in the paper?
The limitations or drawbacks of the SUTRA model proposed in the paper include the potential challenge of maintaining consistent performance across a wide range of languages, especially those that are less commonly represented in language models. While the SUTRA model demonstrates notable consistency in linguistic performance across various languages, there may still be room for improvement in ensuring equal proficiency across all supported languages. Additionally, the effectiveness of the SUTRA model in real-time queries and online scenarios, while promising, may still require further refinement to enhance its ability to provide accurate and up-to-date information from the Internet. Another limitation could be the complexity and computational resources required for training and deploying the SUTRA model, especially in comparison to more established models like GPT-4. Furthermore, the SUTRA model's reliance on a mixture of expert strategy, while efficient, may introduce challenges in managing and optimizing the selection of relevant experts for different linguistic tasks. Lastly, the SUTRA model's reliance on a structured approach for response augmentation may limit its adaptability to unforeseen or rapidly changing information sources, potentially affecting its performance in dynamic online environments.